Planetary challenges take the form, for example, of challenges coming from the physical system that the planet is. Weather, climate, ocean flow, ice sheets and things like that. So mathematics plays a major role there because these are physical systems which are modeled typically with mathematical equations when it comes to the assessment and prediction of risk, of unpredictable phenomena which could put people or their welfare in peril. Mathematics has a long tradition.
A big challenge is how to make the transition towards sustainable forms of energy. We know that there is the wind and the solar power that are free out there, and then there are intermittent sources, and this has to be well managed so that we don't lack electricity when we press on the button. We have a lot of optimization, statistics also to try to model all these phenomena that vary at random, and also optimal control.
As mathematicians, we are looking at the impact of human practices. Botswana was once a semi-arid region, but it's now an arid region. And as a result of that, the amount of rainfall that is falling has considerably reduced. Climate change is a very complex issue. So we have combined with our friends in differential geometry, and we are working together to ensure that we develop the necessary tools that will help us to understand what climate change is.
The specific problem I work on is data assimilation, how to use the data, satellites and various other measurements into climate models. The weather prediction these days over a 7-day time period is roughly about as accurate as it was about 40 years ago over a day or two. So the horizon of prediction has grown substantially, largely because of use of these data assimilation methods, but also because of improvement in the models themselves.
One challenge area of applications would be a better understanding and mathematical modeling of the food system that allows people to predict and help optimize food production, because the world's population is growing, becoming richer, and wants more and better food. We know how to predict water flow and airflow, but how humans on a large scale even predict, migrate, act day to day, what preferences they have, and how to integrate all that. That's a big and very interesting challenge for the future. The issues, the topics don't go away. They make headlines all the time, and they keep us focused if you pay attention.
It never ends. As soon as you figure out some problem, there is a new one that arises. We have to see the problems in a larger scale, and this calls for high-performance computers, new methods, new even machine learning methodologies that we were not using before for these kind of problems.
Mathematicians are essential in almost every process because mathematics, is a tool. It is the engine, it is the blood, of every science, but now it is even proving to be so, in the social sciences.
ICMTV is brought to you from the 2018 International Congress of Mathematicians in Brazil. So for more like this, click on some of these great videos, and don't forget to subscribe for more from the best in science, from everything from mathematics to physics, geophysics and engineering.